everyone, and welcome to this week's episode of Echo Live, brought to you by Denso and the Michigan Space Grant Consortium. My name is Anna, coming to you from the Michigan Science Center's Echo Distance Learning Studio, and today we are here to talk about science in sports. If you are a sports fan, you might know that this is a fantastic time to talk about sports because we are celebrating the Olympics. We've been posting a series of posts on the Michigan Science Center's social media channels all about sports and how athletes are actually STEM experts. But that sounds a little funny. I know that sometimes there can be a misconception that athletes and science, technology, engineering, and math don't necessarily go hand in hand. But today I want to dispel that myth by talking a little bit about how athletes, especially athletes who are at the top of their game, athletes such as the Olympians who are competing right now, actually use math and physics concepts all the time, even if they don't know it. So I'm going to highlight two very important physics and science concepts today and talk about how these athletes use them. Now, today and recently, we've been talking a lot about things that spin or rotate. Now, I can think of a classic example that's maybe more associated with winter sports, but when we think of athletes that spin, I know the first thing that comes to my mind is a figure skater who's gliding across the ice and then pulls her arms in very, very tight and starts to spin. But figure skaters are, of course, not the only athletes who rely on rotation, whether it's their body or their equipment that rotates, in order to excel at what they do. If you can think of another sport besides figure skating, since that's a Winter Olympic and we are here to talk about the Summer Olympics, tell me in the chat, what types of sports use things or that rotate? Now, I can think of a few, but let's start talking about some of those physics concepts. I brought with me a very useful tool because this tool does spin, which is exactly what we want it to do. This device is called a gyroscope, and we actually sell these in the Michigan Science Center's gift shop, but they are very useful for explaining something called angular momentum. Now, those words sound familiar because we've talked about them here on Echo Live quite a bit, but basically, the important thing about the design of our gyroscope here is that when I pull the crank, I'm going to spin the disc that you see in the very center of the gyroscope. It's important that the disc is actually the heaviest part of our gyroscope design here. And in this case, that is 100% true. So let's go ahead and give you a little bit of a closer look. And I'm just going to pull the crank, which is going to spin the disc in the center. And let's watch what happens. Now you'll notice before I get it spinning, if I were to let it go, it doesn't quite stay upright. I'm sure it's possible that someone out there could get this to balance if they got it lined up just perfectly, but we're not here to talk about that as an activity. Today, we're just going to go ahead, give it a spin, and release. Now, instead of falling over this time, the angular momentum, that physics concept that's at work, is actually keeping our gyroscope upright. Isaac Newton told us that an object in motion will stay in motion unless acted on by an outside force. That's exactly what's happening here in our angular momentum demonstration. Unless something else were to come in and knock our disc down, that gyroscope wants to stay upright, spinning exactly as it was as soon as I pulled the crank. The cool thing about gyroscopes is they don't just work if you balance them perfectly. We can also give it kind of a spin off center and watch what happens. So if I turn my crank this time, but keeping my gyroscope a little bit off kilter, you'll notice that eventually, over time, our gyroscope will actually straighten itself out. This is all due to that concept of angular momentum that we've talked about here in the past. Now, of course, you might know that athletes such as gymnasts rely on rotation in order to excel at their sport, but I'm really thinking about bicycles in this case. Cycling is one of my favorite Olympic sports, and cycling is really a prime example of angular momentum at work. Now, we often think that the athlete, the rider of a bicycle, is what's keeping that bicycle upright, but that's really not true. It's really not the entire process. You might know that if you've ever let your bike go on a hill, that it might actually ride away from you and stay completely upright unless, again, it's acted on by an outside force. Angular momentum, as the wheel spins, keeps that bike exactly perpendicular to the ground. Unless something else were to tell it to move, like say an athlete turning the wheel and changing the direction of the force, that bike will stay upright. Now, angular momentum is observed in many sports, right? We said that gymnasts, when they rotate their body, just like a figure skater, rely on that spinning rotation. But recently we've added even more amazing sports that rely on rotation. I'm thinking of skateboarding and surfing, which are both new Olympic sports this year. But all of these athletes, even if they don't know it, are using angular momentum. Now, of course, an athlete isn't spinning in midair using a pencil and paper to calculate exactly how fast or in what direction they need to put their force. Your brain actually does that work for you. It's amazing. Now, we have an exhibit here at the Michigan Science Center that is here right now. As soon as we reopen, it will be open to the public. Anyone who comes in with general admission will have access to our exhibit called Math Alive. Math Alive is all about how we use math in unexpected places. Athletes who are at the top of their game actually are doing calculations in their brain all the time. It might not look like it, but they really are. And the important thing is that these athletes, right, are practicing. Every single time they practice their sport, they're getting better at math and physics concepts. Just like we get better at math every time we practice our times tables or sit down and do some equations for practice. So we're really excited for everyone to get to see Math Alive in person when we return to the Science Center in the fall. Now, I've got one last demonstration to show off another physics concept. So we've got our cyclists up here. We've got our snowboarders over here. So a good mix of summer and winter sports. No matter what sport you play, I promise that you're doing math all the time. But I figure what better way to close out our episode of Echo Live today with something a little bit bigger, a little bit flashier. For this one, I'm definitely going to need some safety equipment because I want to show off angular momentum and inertia at work. Now, Isaac Newton told us something else that's really important. So he not only told us that an object in motion will stay in motion unless acted on by an outside force, he also told us that for every action, there is an equal and opposite reaction. So we mentioned figure skaters briefly, but let's bring it back to figure skaters, or we can think about this in terms of gymnasts as well. Now, when a figure skater spins, of course, her rotation in this case is what's keeping her upright or balanced. But you'll notice that there's a change in the system when she brings her arms in closer to her body. This is exhibiting a change in inertia. When her arms come in towards her body, that is a change in the system. So for every action, there is an equal and opposite reaction. And you might notice that as her arms come in and her distance decreases, her speed increases. So they begin to spin faster. The opposite happens right in the opposite direction. When a figure skater puts their arms back out, the speed of rotation slows down. So equal and opposite, always equal and opposite. So for our last demonstration, instead of figure skating for you all, because I promise I'm not very good at that, instead I thought I would show off one of my favorite demonstrations, which is of course our fire tornado. Since we're working with fire, you'll notice I've got on my lab coat, my safety goggles. I've even got a glove on here to keep me at a safe distance from the flame that I'm about to create right here on the table. And so for this demonstration, we're just going to start off with a pretty large flame here contained safely inside our dish. Now, to turn this into a tornado, we need to add a few things. First, we're going to add a vessel, something that's going to allow air to start coming into our fire tornado here through openings in either side. Now, in physics, we say that heat rises. So right now, the heat from the flame is drawing upward towards the roof or the ceiling that I just added to our fire tornado here. Of course, we want to give a smaller space, just like in our figure skating demonstration. And you'll notice that as my fire that's down in the bottom of the container right now is starting to spin, starting to turn into somewhat of a whirling, swirling tornado. If we want that speed to increase, we just need to decrease our distance. Just like a figure skater pulling their arms in towards their body, as we give the flame a narrower opening to travel through, that is a change in our system. This flame speeds up, gets narrower, and only can exit through the top of our chamber here. Now, of course, just like we said with our figure skater, for every action, there is an equal and opposite reaction. So if we want to slow down the speed of our rotation and the speed of our fire tornado here inside our vessel, we're just going to disassemble it. Now that the flame has a wider opening to exit through, you'll notice that the speed of our flame starts to slow down. Now, of course, we do have an open flame here in the distance learning studio. We don't want to keep it that way forever. So easiest way I know to stop that is to just go ahead and snuff out our flame. So physics and math are a part of everything we do. We hope that you'll get a chance to come check out Math Alive. It's here through the rest of this year. And we are so excited to keep talking about how math and physics concepts are a part of all of our lives, even in unexpected places. So thanks everyone so much for joining as always here for Echo Live. Thank you to Denso and Michigan Space Grant Consortium for allowing us to provide these episodes every Wednesday at 2:30 p.m. If you have any questions, type them in the chat and I'll see you all next week. See you later.